As the Kepler's laws are three laws. The first one being elliptical foci, and the second one being equal areas in equal time intervals. And the third one is the planetary period being constant based on which planetary system it belongs to. The second one, which is equal areas, is predicted in this picture given right here. As you can see that, let's say that in one particular time interval, let's say 1 hour. So this is the sun being at this foci right here. And then let's say the planet goes from here to here. So the area it sweeps in this particular time is from here, this shaded area, which is C. So after a while, again, you're going to check for the same time interval, which is maybe, let's say 1 hour. Then you see that it is covering a distance of from here to here, and it is covering an area of A. And you look at this same planet after some time again, but with the same time interval, let's say 1 hour again. And if you look at it, that it would have been traveled from here to here, but it sweeps the area of the shaded area, which is in B. When you take the mathematics rules, mathematics formulas, and if you find out that the area A, area B, and area C, all three are same. So this is the meaning of sweeping equal areas in equal time intervals. Planetary periods. So the period of a planet square divided by the average orbital radius cube is same for all planets. So look at this planet right here, planet 1, and in the planet 2, this is the little bit far from the sun, and this is very closest planet to the sun. So if you look at this time right here, this planet started making a round trip around the sun. So it is taking this path right here. So let's imagine that it is taking a time of t1. And then if you measure the radius, which is from the sun, center of the sun to the planet's center, so this is the radius r. So if you make a ratio of t square, which is the time period square, divided by the radius square, that would be exactly equivalent of this planet, which is pretty close to the sun, and it is making a radius of r2, and it is taking a time interval of t2. If you make a ratio for that, it would be exactly same. That is, these are the three laws which are proposed by Kepler. Kepler's work improved upon the Copernicus theories by modifying the heliocentric model of the solar system. Gravity is one of the fundamental forces. Once the motion of the planets was predictable using the Kepler's model, the next question was why? Why the planets are moving like that, and why moving in elliptical orbits, and so on and so forth. The planets must be held in an orbit by a force, and without which the planets should hit each other or fall on each other. So there is some sort of a force which is keeping them in an orbit. Isaac Newton was the first one who addressed the ideas of the gravitational attraction. Newton discovered the law of gravity. The discovery was dependent upon the Copernicus model of the solar system. What is a fundamental force? Gravity is a fundamental force. It cannot be explained in terms of any other force. There are four fundamental forces: gravitational force, electromagnetic force, weak force, and strong force. Newton's law of gravitation explains the motion of all observed objects in the universe. Gravity is universal. Gravity is thought to be a universal force because the observed star systems and galaxies behave as if they are influenced by gravity. Matter appears to be the same throughout the universe, therefore, the gravitational attraction must be universal. There is no evidence that gravity is not universal. So nobody ever came with the proper evidence that gravity is not existing. So we still believe that gravity is a universal thing and it is same throughout the universe. The Earth is not a perfect sphere. As the Earth spins on its axis, the equatorial region of the planet tends to be swing outward. So instead of having a sphere like this, you will have a sphere a little bit bulgy at the equator, and at the poles it is a little bit pushed on top. Why Earth is round? The theory of gravity accounts for the Earth's shape. The Earth is round because gravity squeezes it into a spherical shape. So if something has to be squeezed in the smallest possible shape, it has to be the sphere shape. So due to this gravity, the Earth squeezes itself and takes the form of a sphere. The Earth is not a perfect sphere because its spinning motion causes it to bulge slightly at the equator and flatten slightly at the poles. Gravity effect on the Earth. Let's say that if you had some pokey areas or some areas where it is a little bit bulge, then because of the gravity, it would keep on down falling. It would keep on fall down. So downward force due to the gravity pull, because of the rest of the Earth, it would be keep on pulling, and then eventually it just becomes like a small bump, or the whole bump will remain. Just the way we built a sand castle at beaches, and after a few days it'll keep on vanishing and keep all getting smaller and smaller, and finally it'll be just flattened. So let's say that if you have a dent in the ground on the earth, then how would it be closed? So the downward forces due to the gravitational pull of the rest of the earth, it will keep on working at the ends of the dent, and it'll keep on pushing it up, keep on pushing it up, and eventually only a slight depression remains or completely sealed up. The Newton gravity explains the tides. Two factors: gravitational attraction between the Earth and Moon, gravitational attraction between the Earth and Sun. These two are the factors of the tides. The law of gravity successfully explains the occurrence of the tides. The Earth's tides are the results of the gravitational attraction between the Moon and the Sun. Coastal areas experience 2 high tides and 2 low tides each day. You can look at this picture right here. See, we have the Earth right here. It has part A, part B. So let's say that if you have Moon is on this side, then the place where you have part A will have the tides, because the part B is not facing towards the Moon. So there won't be any tides on the part B, but part A will have high tides because of the Moon existing on the same side as the part A. How can we begin to understand the nature? We understand things by measuring things. We measure distance, volume, mass, weight, force, charge, temperature, power, etc. In order to communicate science, we all have to speak the same language. In order to communicate across the world, we use the common language of units and equations. The use of mathematics. Screaming gnashing of teeth. Why math? We must all speak the same language in order to share the ideas and increase understanding. Science is common to the entire human population, so we must use the same language in order to increase the understanding for all human race. Things we can measure must be quantitative. This means numbers and for the numbers to mean anything, we need a standardized system of units. Common unit systems. United States has English systems, system international or international systems. We call this metric. The English system is a product of the Magna Carta. The metric system is a product of the French Revolution. Nothing magical about the metric system. Good science can be done using other unit schemes. Understanding of SI units. The unit of length is meter or centimeter or many other we will see in next few slides. The unit of volume, which is measured by length times length times length, which is a liter, 1,000 cubes, 1 centimeter each, about 0.26 gallons. Or most commonly used metric unit in the United States is the liter. The units of mass is kilogram and gram. My metric. Since you all already know, this is just a revision of everything. So this is the ones place, tens place, hundred place, thousands place, and 10,000 place, and things like that. This is tenth and hundredth and now 1,000 and so on and so forth. Multiply by 10 or divided by 10. So that's why we call it metric. Conversion factor is the multiplier used in changing a quantity from one system to another equivalent quantity in another system. For example, 1 mile is 1.61 kilometers, or 1 gallon is 3.79 liters. 1 pound is 2.2 kilograms. Graphs, table, or statements, so one of the ways to measure the data. Relationships between the measured quantities can be expressed using words, equations, or symbols. A physical measurement consists of a number and a unit or a standard quantity. The standard quantities such as a mile is known as units. The result of every measurement has two parts, a number and a unit. For example, 100 miles, where you have a number which is 100 miles as a unit, or 10 meters, so you have a number and a unit. The most widely used units today are the international units or SI units. So there are some units which are called the base units, which are time, length, mass, amount of substance, thermodynamic temperature, electric current, luminous intensity. These are all called the base units because these are not derived by any other physical quantity. If you need to know them, you just have to measure them by itself. You do not derive them by any other physical quantity. That's why we call them base units. These are some prefixes you would have heard before, but these are the prefixes which represent a number. Something like kilo. When we say kilo, it is nothing but at 10 to the power of 3. And we usually use the abbreviation of K. Mega is 10 to the power of 6. And M, capital M is the abbreviation. Giga is 10 to the power of 9 and capital G. And so on and so forth. And milli is 10 to the power of -3 with small m. Micro is 10 to the power of -6 is the mu. Nano is 10 to the power of -9, small n. And these are the conversion factors from one to another. 1 kilometer is nothing but km. This K stands for 1,000, right? Which is 10 to the power of 3. So that is 10 to the power of 3 meters. This m stands for meters, so meters. Gigahertz is 10 to the power of 9 hertz. This is milli